Hello guys, welcome back. In this slide, we are going to learn about SAP Application High Availability using SUSE cluster. So this image here is showing the cluster architecture. To have a clear understanding and more visibility towards it, we are going to divide this architecture into multiple components. So let's quickly start. Here you see node A. Node A is hosting your ASCS services. ASCS is having message service and NQ log services and gateway server. And your node B is hosting your ERS services. ERS is nothing but your NQ replication server. So here we know that we are implementing this application cluster to achieve high availability at application end. So as we discussed in our previous slides, that high availability should be there at each application service level. So here you see message service, NQ service and gateway service. For this service you can get the high availability from PaaS. For NQ server we have the high availability from this component. For message service we have node B. So whenever you see any abnormal activities, like if node A goes down, node B takes over, so you get the high availability for message service from node A to node B. So node B is your HA node. Alright, so this is the role of node A and node B, which is node A hosting ASCS and node B hosting ERS services. Node C here in this architecture is hosting your additional application services, your PaaS, that is the primary application server, and DB, your database. This part is your database, which here in this course I'm going to take it as SAP HANA, because in our further slides we are going to learn about SAP HANA high availability also using SUSE cluster. So here in this I'm showing it as SAP HANA database. Here you see these are VIP. What does it mean? Virtual IPs. So everywhere, whenever you're going to implement clusters, you have to use the virtual IPs so that your services can float from one node to another. Any physical IP cannot be moved, so we have to make sure that whatever host names and IPs we are referring in your installations and the configuration, it has to be virtual. How it is done, we are going to see it in our further slides. So here you see I have categorized this components into two categories. One is clustered machine and the other is non-clustered machine. In the clustered machine, this is the area which comes under clustered machine. Clustered machine is having one machine that is having a physical name, or let's say the VM label as HACERT01, and its virtual name is SAP HA1AS, which we are going to use it for the installation purpose. I mean this name only has to be come under the installation name. Later on, the next machine is ERS, HACERT02 is the name, and the virtual name again is SAP HA1ER. So moving further, we have this disk. What this is doing here, this is the shared disk. This is the shared disk from where your shared partition that we discussed in our previous slide in the file system, USR, SAP, SID, ASCS followed by instance number, and also USR, SAP, SID, ERS followed by instance number. These two file systems or these two partitions are coming from sorry, one second. So this is coming from this shared disk. Why this why we have implemented shared disk for this? So that these file system also can move from one node to another whenever your particular services are active at any node. Those file system moving along with the virtual IP and your SAP instance. So this is the core of your cluster architecture. One of the important thing that I have skipped, that is the pacemaker. What pacemaker basically does in this architecture or in this configuration, pacemaker keeps on checking the health of node A and node B. So it will be checking the heartbeat of these nodes. Whenever it identifies or it detects any kind of abruption, it immediately going to inform the cluster to take the respective action. Let's say if pacemaker is continuously sending the signal to node A and it does not receive any kind of response, so what it is going to do, it will inform the cluster, which in turn run the SAP commands. Let's say if it has to perform the takeover, it will be running the SAP control command back in the backend, and your ASCS services are going to move from node A to node B. So at that particular time, when your node A is down, your ASCS and your ERS, both the services will be running on node B. And as soon as your node A comes back, your ERS services are going back to this node. And also here you see the NQ replication. NQ replication is for your log entries. Whenever your log entries are getting created in SM12 transactions in your NQ log table, so just to avoid any kind of data loss, these entries will be replicated from ASCS NQ server to ERS NQ replication server. So this is it about this architecture. Thank you.